If you want to use a 3D scan of a part like this to make a fully modifiable and usable 3D CAD model using only free software, you're in the right place. Welcome to Making for Motorsport, where we make more, spend less and go faster. So consumer grade 3D scanners have exploded over the last couple of years, with Creality and RevoPoint putting out some fantastic models that really bring some great scanning results to within the fingertips, the grasp of home gamers and amateurs in their garage. But there is a problem, and that's the file format that these scanners put out, which are mesh files. So that's great going straight to a 3D printer or going into Blender to sculpt something in an organic way. But if you want to do reverse engineering, if you want to take measurements, if you need planes, you need cylinders, you want to modify it, that's very difficult. Now, if you've got the right software, it's a bit easier, but often that software is worth more than the pro grade scanners. So what we need is a way using free software to achieve the same result. Let's find out if there is one.
So the first job, of course, is to scan the part. So I'm using my CR Scan Lizard to scan this, a Vauxhall Corsa C upright. Now the reason I'm scanning this will become obvious in later videos, but for now all we need to know is that I need a 3D model of this that I can easily modify. But it's also a useful part because it's got some very clear geometry, it's got planes, it's also got cast faces. That means that I've got a nice variation of geometry to deal with. Now, it doesn't matter which scanner you're using because actually we're just going to pick up from the STL. So for this, I'll simply say I used dry shampoo and scanned it from multiple angles, combined them to give me this, the final STL.
Which leaves us with this 3D model. Before we go any further, we just need to work out what we're trying to achieve here. If we just wanted something we could 3D print or something that was just purely a copy of what we've got as far as our scanner can do, well, there it is. We've got it, done. Send it to the printer, it's an STL, you can do it straight away. However, that's not what we want to do. So we want to reverse engineer it. So we want to pull out all of the features that interact with other items that give it its form, its function and its fit. So I want to extract all of these points where it interacts, so the steering arm, the strut, the brake caliper, the drive shaft, and extract all that information and put it into another 3D model that I can then modify and change using parameters. So that's what we're going to do. But first off, we're going to remove a few things from this model and simplify it slightly. So we've got all this writing here, all these casting marks, we've got these items here that look like they're a sprue from where it's been cast, which we don't need. So we're going to tidy this up, we're going to do it all in Mesh Mixer. So, hit the music. And there you have it, a simplified, smoothed out model that really is just giving us the information that we really want to see. But as you can tell, it's not aligned with the coordinate system at the moment, which is a problem. So for that, we're going to open up another piece of software. So this is GOM Inspect, and this is a fairly chunky piece of software that generally only the pros get to play with, but they do have a free version. So you can open a new project, import your STL. Now we've got the model in the software, we can easily align it to our coordinate system by using a 3-2-1 alignment, where we pick, first off, 3 points that are on a plane perpendicular to the x-axis, and then 2 points that are on a plane perpendicular to the y-axis, and then 1 point on a plane perpendicular to the x-axis, z-axis even. And there we have it, we've got all of our points in, and you can see it's now aligned to our coordinate system. But you can see z's going the wrong way, z's going down instead of up. So if we flip that, that will flip Z for us going up that way. So we simply go OK, and there you have it. It's now aligned to our coordinate system. Pretty nifty. What we can easily do in GOM Inspect also is we can use the construct function to put planes and get them fitted to our mesh. So if we click there, that is now constructed a plane fitted to all of those points that you can see highlighted in red, all of those facets. And that's great. However, the more we do that, the more they're going to be fitted to the model, and they're not going to align perfectly with the planes that form the basis of our coordinate system, the origin. So that's going to make life very tricky. So we're not going to do that, although it could be a very useful thing in the future. Who knows, you might see that in other videos. But for now, we're just going to save this model and export it as an aligned mesh. So I'm going to put that model into Fusion360. Now I'm using Fusion360 because I like Autodesk products. I know Fusion360 better than anything else. And plus, it's free.
For free!
So you can use a really powerful program without having to spend any money. Now, cards on the table, I am part of the Autodesk Creator program, so I get a fully featured version of this for free, but none of the features I'm going to use here are behind the paywall. Behind the paywall, so they are fully available for anyone to use. So let's get stuck into it. So first off, we're going to import the mesh. Now I always like to use the insert mesh function because that enables us to do a few things, because we have this screen available to us here. So what we can do is we can center it on the origin, and we can also move it to the ground. We can potentially flip up the direction like that, but we don't want to do that. We want to leave, for me, I like Z to be height, so that works perfectly well. So if we look at it from these various angles and we turn the origin on, that works well enough for me. Now what's the goal? We're going to build a fully prismatic model out of solids. So not surface, but solid. So something which we could define in using parameters. If we wish to, we can change, we can measure, and we're going to do that here. And the first thing to start on is to give ourselves a datum right down the middle of the drive flange. So the axis of the axle, if you will. To do that, we're going to do the core trick. This is the killer app. This is the one trick you need to know that will help you out, and basically it's this: create mesh section sketch. So we click on that first and we click that body, and you can see it's already selected this plane, and we can pull this plane through, and we can also set, if we want to fine tune it, we can do that with this box here. And I'm going to take a section, create a sketch on that section there. These orange lines around the spigot on the flange, on the drive flange. Click OK. Now that has created a sketch up here called Sketch 1. I'm just going to rename that and call it the drive spigot section. Yep. And the next thing we do is we right click on that and we go edit sketch. And you'll find it's easier sometimes just to turn these off. Turn off the meshes so you can see this sketch. Now you can see actually we're now in sketch mode, but we can't really select those orange items. But what we can do is the second part of the trick, which is this fit curves to mesh section. So we click that and it gives us this little dialog box here where we can draw lines, we can draw curves, arcs, but we're not drawing them. We are fitting them to this. So we really want to fit a circle to these two circles. So if we go to circle, and we can click on that one, that gives us and you can see there's a maximum curve deviation there of 0.108 of a millimeter. So it's not far off. So if we click OK there, that gives us, and finish sketch, that gives us a surface, an enclosed circle, an enclosed sketch. So we could do anything with that. We could extrude that, we could do whatever. But we're going to go here to axis perpendicular to face at a point, and that's the face, and that's the point, and there's our axis. So if we turn the mesh back on, you can see we've now got an axis running right down the middle of it. Looks pretty good to me. Now, you may have guessed you can use some of these tools to do alignments in Fusion. And you can do the full alignment to the coordinate system in Fusion if you wish. And in fact, there's a whole load of videos already on this stuff. So I will put together a bit of a playlist of some of the videos I found very useful in learning how to do this. And I will put them all on my screen, or I'll put them up here or somewhere or in the description, so you'll be able to look at exactly the videos where I found this from. And by the way, after this video, I would suggest you go and learn everything about design. He has hundreds of videos all about designing things on Fusion using solids, forms, surfaces. He knows what he's talking about. So any questions or any issues with this stuff, check out his videos. I bet you he's got the answer in there. But let's carry on with this. Anyway, so let's start building this model. The first thing I'm going to do is revolve this drive flange. So what we need is to take a section sketch of this drive flange, and we could drag another plane in, but I'm going to construct a plane that's right down the middle, and that's easy to do because we've got a axis. So we can say plane at an angle on that axis 90 degrees, and you can see it's there right down the middle of the drive flange. So that's pretty handy. So we can go to here, create mesh section sketch using that body and that plane, and we click OK, and we've got magically another sketch. So I'm going to call that axle section, and if we turn this off, we can see we have essentially cut that in half. So what I'm going to do now is exactly what we did before. We right click, exit, edit sketch, and we're going to go fit curves to mesh section, and see we're still on circle, so it's just given us a circle, but what we can use is spline, or should we use closed spline, and that will essentially go around, fit that one, and we're going to just draw them all in because why not. So now you can see we've got all of those areas as, again, closed sections that we could extrude, we could do something with, but we're also going to do a little bit of drawing here. So I want to, if we look at the mesh itself, actually there's a fair amount here that could all be extruded and revolved. So obviously we can't revolve these bits here, so we'll cut them off. now we've got a closed area that we could extrude or revolve. Let's do it. Let's do a revolve extrusion. We've got the profile selected. We have the axis there. That looks pretty good. So there you have it. That's the first kind of section done. If we bring the mesh back in, you can see that in many areas, come on, you can see in many areas, it's about bang on. It's not many, it's kind of sharing the space pretty well. However, we can see here that it's following the contours of the mesh. And as you can see, that's not quite a perfect barrel, a perfect cylinder. And it is, because I've got it here. And you can see there's no taper on that. That is a nice parallel-sided cylinder. So what we're going to do, because of the way we're modeling this, we still have our design history here, so we can go back and we can actually go back and change the mesh, this drawing that it's defined on. So we can go back, edit sketch, and instead of just blindly following this, we can actually put some rectangles into it. And we can, yeah, look at that, looks about right. Yeah, that, and we could fill this whole area with rectangles, and we could start knocking it out and making it into shapes that we actually like the look of, to give ourselves something to revolve. But we're going to do one section better than that, and we're going to use measurements. So we've got we have our Mitidoyo-san, and we know that that drive spigot to locate the wheel is 56.49 millimeters in diameter.
So what I'm not going to do here is go through every single step, because this is essentially just 2D drafting in Fusion. You can use constraints in the same way. You can interact with the mesh section sketches in exactly the same way as you would do any other drawing. So it really is dead simple. So if you want to create a sketch based completely on constraints that you can come back and easily modify later, now's your chance.
So now you can see that we are looking far more like an engineered piece, like it's got actual cylinders that you can define, that we can go in. If we don't like that diameter, we can go back and change a number, and all those changes will roll through. How's it looking? Yeah, we still got it fairly close to the model itself. So now we're going to try and model this steering arm. So to do that, so we can do the same thing again. We're going to create a mesh section sketch, click the body, select that plane, which is the one we're looking down on really at the moment, and then we're going to select the right position for it. Just move it down here, and you can see there that one's cutting it pretty much through the middle, so that's the one we want. So I'm going to click OK to that, and we're just giving us another mesh section sketch, so we'll rename that one steering arm, and we'll do as we did, go in, edit sketch, turn off the mesh and the body so we can see it, and that's the job there. So again, create, fit curves to mesh section, close spline, we'll just create a close spline based on that, and we will create a circle based on that. And there we have, again, we've got a closed section we can do something with. So what I'm going to try and do is I want to create this body and I want to join it to this body. So I'm going to cut it off a fair amount inside this body. but I don't want it to interfere with any of the revolved sections. So here it may well do. So we'll cut that off, and then we've got a separate section here which we can extrude. So let's do an extrude. So go back to our solid tab and we go to extrude and we go 2 sides. But let's put the mesh back on. Let's see if we can get that. Let's have it as a join. Now you can see the top level, top surface on that kind of somewhat tapers. So I'm going to, and this surface here is actually machined. So this is the raw casting coming through, and then you've got, or the forging, then you've got the machine point there. So I'm going to extrude on this side enough to give me that much kind of a space, because we're going to come in and do this in a slightly different way, and we're going to do that on the other side as well. We're going to have it so you can just see it. So it gives us pretty much all of the arm. You can see that looks pretty good. It's quite close, but you've got all this material on the top and the bottom that we couldn't do anything with. So what we're going to do is, what I want to do is I want to have a plane that runs pretty much down the middle of there that I can then do another sketch on and then remove. So we need a plane down the middle of there. Now the best way of doing that is simply to go back into this sketch and to give myself a construction line that runs broadly down the middle. Highlight it, turn it into a construction line. Turn the bodies on just so I can organize it. And then we can do construction plane at an angle. The line is already selected, so I just do 90. And you can see we've got that there. So now we can do our same trick again. We can go back to the mesh tab, create mesh section sketch, click the mesh, click the section, section plane, and there we have it. So now we've got our mesh section sketch. We can simply go in, edit sketch, and do pretty much the same thing we did before. And first off, we'll use fit curves to mesh section. Now I don't really want this to be absolutely bang on. It doesn't really matter. So in order to get a better, smoother spline, I'm going to up the tolerance here. And that should mean I get something a little bit more usable. So because I'm going to use this shape to cut out, I'm going to give myself a little box there. So now we've got the outline. Now I'm going to tweak that because I'm not quite happy with the way it scopes in and out, because it doesn't have to be absolutely bang on, but I want it to look good and look like there's a nice smooth kind of taper there.
So now I'm using the spline tool. I'm also using constraints and measurements off the part itself to get what I think is going to be the most representative profile for this steering arm.
So now I've got everything defined, we can finish sketch, and we can pick the bits we want to use as a kind of a delete tool. So we go to extrude and we use cut, and we can pick all of these bits that we want to use as the tool to cut this down with. Again, we go to two sides. We can turn the body on. It doesn't really matter too much. The extents, because we're not intersecting any of the bodies. And there you have it. Turn off the construction, turn off the sketches, and we're getting pretty close to what we should have. And that's the core of the techniques. So let's just do that a few more times for pretty much everything else.
So it's a dead easy set of instructions. First off, you create a mesh section sketch, then you right click on that new sketch and edit it. Then you fit curves to mesh section, and then you've got some lines that you can interact with the same way as any other sketch. And those sketches then you can use in the same way as you would do any other sketches on Fusion, and you can extrude, you can revolve, you can loft, you can do pretty much anything. And then once you've got those solid bodies, you can then modify those in the same way you would do with any other bodies. You can chamfer, put fillet radiuses on and use them as cutting tools, whatever you want to do. So it really is quite simple and very powerful, but it does take a long time.
So after about 2 or 3 hours of modeling, you can see we've got a model there that's fully prismatic, fully editable. You can go back and change it in any way you want, and turning the mesh on, it's not that far off. Now we can go back and we could tweak it and change it and make it absolutely perfect, but that is good enough for me. So hopefully you found this useful. If you have, then please hit the thumbs up button. This is just a really kind of compressed summary of these tools. If you want to know more about this kind of stuff, then head over to Learn Everything About Design. It really is a fantastic YouTube channel, and check out the playlist for all the other videos that I've watched trying to work out how to do this. So if you're still watching now, hit the thumbs up button please. It really does help. If you've enjoyed this, then hit subscribe so you don't miss anything in the future. And if you really do like it, then consider heading over to the Patreon and joining these lovely people heading down here. But that's it for now. So thank you for watching. Be good, and if you can't be good, don't get caught. Oh, bloody hell. This takes ages.